So, well, the simple version is just to tell you what the terms in the equation mean, which is that E means energy, and that's equal to m mass times c, the speed of light, squared.
Energy can be measured in joules, mass of a particle could be measured in kilograms. So if you're going to relate them, you have to relate them with some factor, and the factor that does it is this square of the speed of light.
Taken at face value, it means that energy is equivalent to mass. So that if you were to look at Newton's laws of motion and say that masses attract, this now implies that energy is attracted by another mass. So if a light wave with energy goes near a planet or the sun, it's actually bent by it because it's attracted. So it's saying that energy is equivalent to mass.
The consequence of it is quite dramatic, because the speed of light squared is a huge number. The speed of light in meters per second is 3 times 10 to the 8, 300 million meters per second. You square that and you've got, oh rubbish, they're 9 times 10 to the 16. So you've got of order 10 to the 17 as a conversion factor. So a very small amount of mass is equivalent to a huge amount of energy.
In physical terms, what it means is that there is actually an energy associated with mass. It's something that just sort of falls out sort of almost automatically from special relativity, that it's just something that comes out of the equations. But obviously it's an incredibly powerful result, because it basically means that whenever you've got a mass, you have a source of energy. And so, you know, if you have a fusion bomb, for example, you actually convert some of that mass directly into energy. But it basically is another way of saying that mass is just a way of storing energy.
But it's not even the right equation. The proper equation is E squared equals m squared c to the 4th, plus another term involving the momentum, which is an extra p squared c squared.
The mass in E equals mc squared can either be the rest mass, and that's what it's usually thought of. That's where the object isn't moving, and so it's actually just got an intrinsic mass, and so it's got an intrinsic energy associated with it. Or it could be what's known as the relativistic mass, and if it's the relativistic mass, then it's including the momentum, and I think I'm probably agreeing with Roger. In the textbooks, you'll often see the bare mass is m with a little subscript 0 beside it, just to make it clear that that's not including the momentum of the particle.
The whole equation is never explained, because people like you don't want us to write down equations because they're boring, ha ha. But if you do it all properly, that's what it is. And if you don't do it properly, then you can't explain why energy is attracted to gravitationally to objects, nor can you explain how a photon, which doesn't have any mass, behaves the way it does.
I think an interesting aspect is, why is it the square of the speed of light? Why isn't it the square of the speed of sound, which is a much lower number? And for that you have to look at what Einstein did, what Albert Einstein did when he was coming up with this theory of special relativity.
Without any extra work, it sort of falls out of the analysis of special relativity, that it's just a result that comes along. And it's very nice when you just get a result that just sort of falls out without any extra work, but actually on its own has huge, amazing implications for the laws of physics.
The people that I've spoken to, and when I give public talks, the people who attend it certainly have an idea that you've got energy and mass. I don't think they often realise quite how significant it is, and quite how broad that equation is in explaining phenomena that we experience. They just tend to think of it in the world of particle physics or something rather extreme, but in fact it accounts for the binding of atoms, right? If you've got the constituents of atoms and you just measure their mass, then you put them together, the mass drops. And the mass drops because of the binding energy, and the thing that explains that binding energy is E equals mc squared.
The correct equation, even if the momentum is 0, is E squared equals m squared c to the 4th, and if you take the square root of that, you can get negative energies coming out. And Dirac noticed this and interpreted the negative energy states as the antiparticles. So you now get something for nothing. If you use the correct equation, you can take the square root, come out with a negative energy solution, and then interpret it in quantum mechanics as the antiparticle. And he predicted this well before anybody did the experiment and discovered the positron. So the proper equation is much richer the public can't cope with anything more complicated than E equals mc². And even that's so full of meaning.